because it's called being a little bit hyper. A little bit. Hey, what about this? We had to find the value of angle N for number 14. So that means we've got to figure out what X is first. Well, my consecutive angles are equal to what? 180. Some of you, there you go. Do I need to go on? Okay. That's what you need to do, Justin, to set up number 14. Once you solve for X, whatever you get for X, you put that in place of your angle N, okay? This number 14 was 103 degrees. That angle N was 103 degrees. That was what you were solving for, okay? 29? No, you said 28, didn't you? All right. Yes. All right, 28. You did say 28. All right. It looks something like this. NKL. We are told that this is a rhombus, and we're told that this is 5y plus 5 and 8y plus 7. Okay? Nope. If it's a rhombus, what do you know about the diagonals? They're perpendicular, which means it's a right angle in there, right? Which means I've got what kind of a triangle? Now, I'm not talking about rhombuses anymore. I'm talking about a triangle, which is total to what? 180. That means 5y plus 5 plus 8y plus 7 plus 90 is equal to 180. You said what? What did you set equal to 90?
5y plus 5 and then 8y plus 7.
You added those together and set it equal to 90? You can do that. You still should have gotten the same answer. 13y, that's 102, equals 180. 5 and 7 is 12. 12 and 90 is 102. Then I'm going to subtract 102, and I get 78. 13y is equal to 78. Somebody help me out here. 5, 6, that'd be it's 6. Y is 6, I think. Let's see if that's right. Okay. So then if it's 6, I'm going to plug it back up here. 5 times 6 is 30. 30 plus 5 is 35. For that angle NKL, that was the one we had to find. Okay? Any other questions? Any at all? Folks, this is when you really have to turn it on. You got to turn your brain on every day you come in here. Okay? Any questions at all? They're in here. I really don't. Okay? I don't know why the kites are in here. Kites are something we fly in the air. Kites are not something I want to teach about in geometry. Crazy. But you're going to see them. And the thing you need to remember is this right here. These two sides are going to be congruent to each other. We're just going to, let's say if this side were 10, then what's AD have to be? 10. That's simple enough. And that it appears that segment BC is longer than segment AB. Do you agree? So let's just say, for example, that if side BC is 14, then side CD would have to be what? It would be 14 as well, okay? Now, typically, we're looking at side lengths in trapezoids. There are the properties. Beautiful. It's looking like 661, that theorem says, if a quadrilateral is a kite, then its diagonals are perpendicular. That's kind of interesting. I've never seen a problem like this, not to say it won't be on there. 662 says if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. That means either exactly one pair. Angles B and D are going to be congruent to one another. Excuse me, not A and C, and you can see that right here by the way they have that written, okay? Kites, there they are. I just want you to I want to point out to you potential things up here with the perpendicular diagonals in the kite. What kind of triangles does that form in that kite? Right triangles, okay? Right triangles. If I'm given two sides, then I could potentially have to find a third side using what theorem? The Pythagorean theorem. So remember that, okay? I may have to use the Pythagorean theorem here. If you're given two sides and you're asked to find a third side, that's the way you could find it. Keep that in mind. Okay? Now, the Pythagorean theorem, that's just something you need to keep in the back of your head. It says a blank is a quadrilateral with exactly one pair of parallel sides. Switching gears. No, look down here at the bottom. What kind of it's a trapezoid. A trapezoid only has one pair of parallel sides. And in our picture, it has to be the top and the bottom. You know what a trapezoid looks like to me? You know the things in the circus that the elephants will put one set of their front feet on? Oh. That to me is what a trapezoid looks like. Now, that means the top of it has to be parallel to the bottom of it. Each of the parallel sides is called a base. I refer to them as a top base and a bottom base. Please write this down. Okay? Top base and a bottom base. It says the non-parallel sides are called legs. And it's there on the picture. Okay? Sometimes they're going to be congruent to each other, sometimes they're not. And then it talks about base angles of a trapezoid are two consecutive angles whose common side is a base. So that means you've got one set of base angles here at the top, here in green, okay? And then you have your bottom set of base angles at the bottom. Oh, that would be at the bottom, wouldn't it? Bottom set at the bottom. And notice something about those angles. Sometimes they're going to be what? Sometimes they're going to be congruent. Sometimes. Certain times. Let's look at it. When? If the legs of the trapezoid are congruent. The trapezoid is called an isosceles trapezoid. Okay? An isosceles trapezoid. It says the following theorems state the properties of an isosceles trapezoid. And it's got all of those theorems there. No, the extra credit question yesterday was rectangle or square. Yeah, a lot of people did. A lot of people put rhombus. But the extra credit, and I'm almost finished with that set of papers. If I can get to them this afternoon, I'll return them to you. Look at these. Let's see how we're going to use these theorems, okay? Theorem 665, it's called a biconditional statement, so it's true both forward and backward. I can read it either way, and it's going to work. The measure of angle A. Folks, how do I determine? First of all, I would have to turn my paper sideways because I always want my trapezoid with the parallel bases up, and I want those on the top and the bottom. So I would turn this thing this way and look at it like this. That would be CD. You don't have to do this because you just turn your paper. I can't turn the smart board, okay? Kind of does, yeah. Okay. Now, I want to look at it like that. Is this an isosceles trapezoid? Yes or no? How do you know? Both of these legs are congruent. They're marked for me. If this angle C is 100, no. Go back and read it again. D is going to be 100. Look at this. It says if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. Base angles are congruent in an isosceles trapezoid. So D is 100. But then, how do I determine A and B? Consecutive angles are what? Equal to 180. So what is angle B? 80, which it's also a base angle to angle A, so what's angle A have to be? 80. Hey, this is a where? Okay, you understand that if base angles are going to be congruent in an isosceles trapezoid. So this is 100, so that's 100. Think back to parallel lines, Brandon. What kind of angles are these right here with respect to parallel lines? No, they're on the same side. Same side interior angles, which are also called in some textbooks consecutive interior. What do you know about same side interior angles? They're not congruent. They're equal to 180. Yeah. You subtract these two angles. So you take 180, take away 100, we get 80, boom. Okay? Base angles are congruent, so my two bottom bases will match. Okay? Let's look at another one. It says KB is 21.9. MF is the whole thing, 32.7. We got to find FB. Nope. FB. I got to find that piece right there. What do you think is going to be true about, just look at it, even without knowing any theorems or anything? No. FB and JB are going to be what? They're going to be congruent to each other. And, hold that thought, and KB is going to be congruent to MB, which means, that's exactly right. If, I want you to write this down, if FM is equal to JK, then we're going to take 32.7 minus 21.9, and what do we get? I don't know what we get. Yeah, that's right. You got to make sure you got to know all your figures. You got to make sure that you know all the properties of all the figures. Some of you still don't know the properties of the parallelograms. How do I know to do that? Because, let me erase this again, okay? You can kind of look at this one and tell that these two pieces are going to be congruent to each other, right? And I can kind of look at these two little pieces and tell that they're going to be congruent, right? It says that MF, the whole thing, if MF is 32.7, then what is JK going to be? Look at it. The same thing. So if I've got, if you'll bear with me here, KJ, if the whole thing is 32.7, Brandon. And we've got to find K, or we know that KB is 21.9. Do you see? That's just segment addition postulate, y'all. Right. Does that make sense? So the whole thing, take away the little piece, gives us segment JB. Okay? Yes. And they better equal what? 32.7. Okay? Does that make sense? Yeah? Look at the next one. It says, that was my shoe. Huh. I don't know. I don't know. No, if it's a rectangle, then we got no, we got other issues. Let's look. This is a trapezoid. How do I know? The way it looks. How do you know, Smarty McFarty? Because the top is parallel to the bottom. That's how we know. And you're right. I can look at it. Come on. I agree.
Wait, so it can't be shaped any different?
No, because the trapezoids, you're typically going to see them as isosceles trapezoids. Okay? Now, how are we going to find the measure of angle F? E's going to be 49. Oh, listen at you. 180. Take away 49 is 131. You got it. That's what angle F is. So if angle F is 131, what's the measure of angle G? 131. Questions on that at all? You are. It's the fan. Don't tune me out. I appreciate your honesty, though. But don't tune me out. Okay?
Oh, yeah. I don't even know what to do.
Somebody explain it. Zoe, tell him. Shh. Shh. Go, Zoe.
E is 49 because H is 49 in the unit. And then the whole thing is 180, so you take 180 minus 49 and each one is 1. And we had to find measure of, so,
Base angles are congruent, which means 49 and 49. Okay? Hold that thought. And then, because this is actually, remember we're dealing with parallel lines, because these are same side interior angles, this angle, angle E plus angle F will total 180. So all we do is take 180, take away 49, and we get 131. Okay? Yes, sir.
Remember with triangles how like you were talking about these things point to the angles that are congruent?
Yep.
Like, I was wondering if like
That,
is that the same thing?
it is the same concept, absolutely. Do y'all see how the little congruent marks kind of point to the angles that are congruent? If that will help you. Do you see, are you listening to me?
I thought you were talking to me.
I'm talking to you. Did you hear what he said? No, okay. Do you see these congruent marks right here? The red congruent marks? Do you see how they're pointing down to angles E and H? That means that those two angles are congruent. That will help you, okay? That's a good tip. That's a good trick. Yeah, that's a good trick. All right, look at the next one. It says JN is 10.6. Cody, you with me? Okay. NL is 14.8. Dennis, you good? Okay. We got to find KM. Why? It's the same line.
JL is congruent to K.
JL is congruent or equal to KM. So add them together. 10 plus that number. 10.6 plus 14.8 is going to be what? Say what, Kevin? Because remember a while ago, these two diagonals are always congruent to each other. So if this, hey, if that piece right there is 10.6, don't we have another piece of a diagonal that's 10.6? That little piece, what's this one, KN? 14.8, and can I say 14.8 plus 10.6 is 25.4? Do you see it? Guys, do you see this? If you're a visual learner, this is easy for you. If you're not a visual learner, this is not easy, okay? Hands-on. I'm not much of a hands-on. No, I don't do well teaching that way. I need to do better at that. But
So that's an equation right there.
that's a squared equation, okay?
You're still going to make it for each other.
You would, why?
You got to solve the angle.
Because you have to solve for the angle. We're not going to actually solve this, but I do want you to put, because angle S is congruent to angle P, then we would have a squared plus, let me rearrange that. 2a squared minus 54 equals a squared plus 27. And then we would solve. We're not going to. Yeah, we are. Yeah, we're going to. We are. What am I going to do? No. Subtract a squared. Okay, let's subtract. That gives me a squared minus 54 equals 27. What now? Do you guys agree with that? I get a squared is equal to 81. What now? Find the square root of both sides. A is equal to 9. Now, where do you think that would be in your list of answers? It's probably going to be the first one. Let's go back and read. Is that what we had to find? It is. It says find the value of A, so that's what we did. We just go back and plug it in. Yep. Yep. It got rid of this. No, it's just like having 2x minus x. What's 2x minus 1x? 1x. What's 2a squared minus 1a squared? 1a squared. Okay? AD is 12x minus 11. BC is 9x minus 2. I want you to find the value of x. I want you to do that one on your own. And I want you to try number 6 on your own. You guys can do both of those problems. What am I going to do with AD? What do we know about AD and BC? They're congruent. They're equal to each other. Good. I'm going to substitute the expressions in here. So we got 3. All right, here we go. What about it, Brandon? Go ahead. Okay, go ahead. You got this. Here we go. Up, folks. Somebody said, they've said it every class today, almost every class today, because you can see it on the smart board. I don't know what happened. I don't know. All right, tell us what you're doing. Lefty. All right, go ahead. Okay. Shh. Take the square root of both sides, good. How many of you had X's 4? Hands up. Do you have questions? Do you see what you did wrong? Okay. Excuse me. Ladies and gentlemen, we subtracted 2x squared from both sides. That's all right. And then he added 13 to both sides. Okay? Then he divided by 2. He got x squared 16, square root of both sides, x is 4. Very good. Very good. Questions? Other questions? Yeah. Question. The problem says that this is an isosceles trapezoid. Okay? And in an isosceles trapezoid, we know, stop talking, that the base angles are congruent, right? So we set them equal to each other. And we solve. Okay? Other questions? No? All right, so look, somebody said, we're back to mid-segment again? Yeah, we're back to mid-segment again. This is easy, though. The mid-segment of a trapezoid, we treat it the same way. It's going to be 1/2 the sum of the top base plus the bottom base. And that's pretty simple to remember. It says the mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. I would rewrite it this way. FC is equal to 1/2 of AB plus ED. Now, are we going to have every trapezoid labeled that way? No. I would write this as my formula. The mid-segment is 1/2 of the top base plus the bottom base. That's what I would do. Okay? The mid-segment is equal to 1/2 the top base plus the bottom base. Pretty simple. Okay? Pretty simple. Now, how are we going to put that into play? Flip the page. Flip the page. Okay? Everybody have it? Top base plus bottom base. How many more examples? 2, that's it? Here we go. Find EF. Okay? What's the formula? Here's the thing you look for. AE is congruent to EB. DF is congruent to FC. That's a good thing. I'm going to have my mid-segments equal to 1/2 the top plus the base. And I'm going to show you a shortcut. I got to find EF. That's mid-segment. What is the length of the top base? 13.5. What's the length of the bottom base? That's supposed to say bottom. So that's 1/2 of 21.5. Folks, what do you get?
Wait, you divided by 2?
So one more time, Michael. 10.75. Is that what everybody got? Yeah? Is that easy? Isn't that easy? Okay, it's 1/2 the top plus the bottom. Right on. Any questions? Look at the next one then. Now this one's different. I got my mid-segments equal to 1/2 the top. What is wrong? Plus the bottom. Well, what's the mid-segment this time? 16.5. 1/2 of, what's the top? Look, by the picture, it's 25. It could be X. If I put X here, then I'll put 25 last. If I put 25 here, then I'm going to put X last, right? Times 2. Do you know why you can do that? Mathematically, watch this. What's the reciprocal of 1/2? Oh. So you mean if I multiply this side by 2, of course what I do to one side, got to do the other. Write this down. My 2's gone. What's 2 times 16.5?
33.
And then aren't I left with 33 is equal to 25 plus x? All right, look what happened. In order to get rid of that fraction, if you multiply both sides of the equation by 2, that eliminates the 1/2, okay? What you got, Justin? Okay.
Are you going to multiply by 2 every time?
Yep. If you're given this mid-segment. Okay, look at the last problem. Okay, I had to find the mid-segment, so I took half of this sum, right? Over here, I'm given the mid-segment, so I'm going to multiply it by 2, 33. I'm going to subtract 25 from it. Mathematically, that's what I do. And my base is 8. And go back and check it. Can I go back and check it?
Yeah, okay.
What's 8 plus 25? 33. What's half of 33? 16.5. So see, I have a way that I can go back and check these problems. Okay? Questions? All right, now, hold that thought on this because I'm not sure that's what you're going to